Well, I mean, it's the 22nd of January, so I feel it's still okay for me to say Happy New Year, maybe for one more week or so. Welcome to this sixth webinar in our series with Professor Chris Jones. He's the Chief Scientific Advisor in the Department of Science, Technology and Innovation, and myself, Elena Simpel, Director of Research at the ODI. Thank you so much for joining us. I'm glad to see so many of you registered and so many of you are back. Before we start, just to remind everyone that the webinar is being recorded, and we are going to share it on social media. We're also going to promote the content in our email newsletter, Week in Data, and we'll keep a recording on the ODI website and our YouTube channel. And of course, would like to always make the most out of the very rich content and conversations we have in these webinars to promote them in future ODI communication. Would like to ask you to add your questions to the Q&A, and we'll try to answer them in the second part of the webinar. Just before we introduce our speaker today, I've mentioned this is webinar number 6 in the series. We had 5 so far from a range of experts from big tech, from academia, with backgrounds that are more or less technical, but all address very important questions in data-centric AI today. And you can find them all, as I said earlier, on our website. We have a dedicated webinar page where all the recordings are listed, as well as on our YouTube channel. But let's move on to the reason why you're all here today, which is our speaker, Professor Chris Johnson, who is, as of last year, I believe, with the Department for Science, Innovation and Technology. Before that, he was a Pro-Vice Chancellor for Engineering and Physical Sciences at Belfast. And before that, he was Head of Computer Science at Glasgow. Chris's research and his interest, he's going to tell us more about it today, but generally are the intersection between cybersecurity and the engineering of safety critical systems, and AI and the latest advances in AI definitely fall in this area. Today's webinar is going to be a bit different. We thought, given Chris' work, it would be more suitable to have a more of a fireside chat format rather than a presentation, to make it more interactive and also give you the chance to ask questions. So by all means, don't wait until our chat to pose those in the Q&A. Welcome, Chris.
Yeah, hi everyone.
We are very, very glad to have you here. I'm going to stop sharing so that we can have more of a conversation. Maybe I'm just going to start by asking you to tell us about your current role and the way it relates to AI and data.
Yeah, so I've been in post 7 months, and I'm Chief Scientific Advisor within the Department for Science, Innovation and Technology. The department was formed about 2 years ago. It depends how you count it, but all of UKRI is funded through the department. So when we come to Treasury and Spending Review, we have to make the case for UK investment in research, both at universities and at what are called public sector research establishments. So NPL would be a good example of a public sector research establishment. DCAI is also responsible for a series of what are called arm's length bodies, and they also have a research function. So the Antarctic Survey, the Met Office, Ordnance Survey, they're also all funded through UKRI. People may also have heard of things like the National Data Library. If we just sort of move towards the AI part, And the Matt Clifford AI Opportunities Plan was kind of developed and then led through to cabinet from within the department. So, you know, the scope of the kind of funding that goes through is about £13 billion each year. We're also responsible for funding our external UK collaborations. So the engagement with Horizon Europe is organised and flows through department. Also things like Copernicus and the Space Agency. And the nature of the department has changed radically over the last 6 months. So we've also become the centre for the digital part of government. And so yesterday there was an announcement about a government data wallet, if you like, holding a common. The way that the public will see it is as an app where you can get hold of national insurance details, your driving license, your passport, etc. And also within the department, we have the AI Safety Institute, and we also have ARIO. And so we have multiple roles within machine learning or artificial intelligence. We fund most of the UK public research in that space. We also are responsible for regulatory innovation. So the Regulatory Innovation Office is within the department. And what we do there is give advice out to other arm's length bodies about how we can manage the tension between, for example, privacy, public safety, and the need to innovate and drive the economy. And then the third area, obviously, as I've just said, is the use of machine learning within government to provide benefits to the citizens through interaction with government held data, and also to enable, for instance, commercial access where that's appropriate. And I mean, each one of those areas has developed incredibly fast. I mean, I was announced in my role by the previous Secretary of State, Michelle Donovan, but I actually started work at almost the same time as the new ministers did within DCAI. Yeah, and my job is two things. So I ensure that policy has a relationship to science. And so I meet all the exec chairs and the head of UKRI about once a month. And then the other part is to put science into policy. And so, for example, people will have seen, things like the Online Harms Bill, for instance. Yeah. There are situations where people, from a policy point of view, might want to restrict access to certain sites, and then you have to explain to people how DNS and other forms of the internet infrastructure work so that the policy is actually achievable. Yeah, so there you go. That's everything.
That sounds interesting and varied, and certainly in this space where there's so much going on in terms of technology advances, but also regulatory leadership. It's quite an interesting time to be operating in that context. So perhaps for the audience here today, I see more and more people are joining. I know when we spoken before, you said that you are interested in the use of AI in safety critical systems. In healthcare, you've also mentioned that DCAI is also looking at the use of AI in public service delivery for the benefit of citizens. So maybe tell us more from your point of view how AI is used or should be used in these safety critical situations, and perhaps whether there's any success stories in the UK that people should be aware of.
I think traditionally in safety critical systems, safety critical software, we've relied on determinism and testing as the two kind of key things that we're looking for. So if you build up a canonical set of tests for let's take an autonomous vehicle, well, that's a good counterexample. Let's say a industrial robotics system which meets a relatively limited set of environments on a pedestal. You can build a training set that exposes the robot to a certain set of environments, and you would hope, without any form of learning, that it would respond in the same way given a certain set of stimuli. I know it's a lot more complicated than that, but that's kind of the traditional view. The problem with that in the past has been that we can't test everything. So even in a controlled environment, we can't envisage all of the combinations of input that the software might meet at any particular time. And so standards like 26262, which is a software standard for vehicle design, or 61508, that's for industrial systems, including some aspects of robotics, what they did was they didn't focus so much on tests, but the development process. So in general terms, the way you design a safety-related system is you identify all of the things, or as many of the things as possible that you think might go wrong. You work out what the probability and the consequences are, which is a definition of risk, and then you allocate resources very roughly in terms of the contribution that the software makes to provide protection to the public. That's just a very, very quick summary of how it's done traditionally. I grew up with space. I grew up on the NASA European Space Agency style projects, and also worked a little bit with the SpaceX teams. What happens when you put machine learning in is things change radically, because it's what you're testing, or what your system is delivering in conventional software is a series of algorithms, and you're putting development processes in to make sure the algorithms don't contain errors. With machine learning, and as the people on this webinar will well know, I don't need to tell them this, it's data-driven. And
maybe it's worth repeating where the difference is.
So, I mean, okay, the algorithms from the outside can look complicated, but actually, in general terms, they're not that complicated in most cases, the machine learning algorithms. But the scale of the data and the way, for instance, in statistical methods, the way in which the weightings that are derived from the data emerge is hugely complicated. And so the point being that if you test the system over a period of time and then retrain it, you might then have to repeat all of the tests again, because you can't predict whether any of the results that you had before apply. So you kind of got a catch-22, which is that the reason why you want to use machine learning is that you can retrain systems and be adaptable to changes in the environment. With a safety-related system, the problem is that if you retrain it, you've got the massive cost of establishing that you haven't trained it to do something dangerous. And then you have to throw into the mix ethics as well. So a lot of the early work I did was with military systems. And do you have, so an example of an ethical principle for military systems would be proportionality. So proportionality is that your system will have the smallest possible effect that you can, or that the outcome is proportionate to what the effect is that you're achieving. And, you know, there are things like human controllability, which is also an ethical concern. And when you deal with conventional systems where a human is largely in control of what the system is doing, that is relatively easy to demonstrate. But where you have adaptive systems and machine learning tools where behaviors might emerge as a result of interactions with the training set that you didn't really understand, you know, who's responsible? And that's not just that might sound like some sort of scientific nerdy style explanation, but I was an expert witness at Grenfell, and I think it's really important to understand that down the line, automated and systems and machine learning tools could influence the outcome of tragedies on that scale. And so I have a real care to make sure that the UK is a leader in the use of machine learning in these more critical technologies, but I also want to be confident that I can sleep at night in terms of having the right processes in place to guarantee public safety. It's a difficult balance.
Yeah, absolutely. I have to just add some.
I can't. Can you just,
am I back now?
Yeah, that's better.
Excellent. So my microphone is. But so I come, as I was telling you at the beginning, I come from an area in AI that is a bit different, that deals with symbols, categories, So the idea there is that instead of learning from data and then trying to figure out what long, very, very long sequences of numbers mean, you encode in a computer how that world of that system looks like. So now you have two issues with that, like you were saying, right? So when the world changes, you have to catch up and keep updating the rules and the categories.
My PhD
looking at the data, right?
Yeah, my PhD is in symbolic logic, right? so yeah, I totally understand that.
But there is a counter argument, right? Because we as humans feel that if it's logic and if it's encoded in that way, then you will be able to follow it, forgetting the fact that you'll have a million of those rules to follow. So no one will be able to understand and summarize what is going on.
Yeah, like I worked on what's called executable temporal logics. And so we were using mathematical not statistics in the way that I described it, which is the way most people think about machine learning today, but using logical abstractions and rules of inference to derive properties from those models. And exactly as you say, there's a gap between what your model can represent and the full details of the environment that you're wanting to model, and there will always be something missing. As you say, you end up looking at a database of millions of rules, not knowing exactly how each component of those rules interacted. But I think what's really important is throughout the world, there are really good techniques emerging to deal with both sets of issues, whether it's statistical AI or whether it's symbolic AI. I think things like LIME, which is a local interpretation of models, that method says you may not be able to understand everything, but here are the key properties that we really want to understand. Another method that I really love is something called counterfactual fairness. So I think I want to the most important thing to get across to people is I don't think of machine learning as purely a technical challenge. I do think that the ethics of what we do are really important, and fairness. The example I use, which comes from the Competitions and Markets Authority, another part of government, is that online sales retailers have used observations about how customers behave to filter the offers that other people may receive. So when you enter into a site, the product that you're looking for, if somebody from your postcode defaulted in payment previously, then they may decide that you couldn't afford that product, and therefore your retail opportunities are determined by the algorithm, not by anything else, and that's not fair. Yeah. So counterfactual fairness, what that does is a series of tests that say, if you've got a certain set of results from one group of the population, if you give another set of the population as input, the results should not have unintended consequences in them. And that, to me, I use that all the time because I don't want to discriminate as a side effect of an algorithmic prejudice, if that makes sense. So these things are coming through. One of the Atlas, MITRE, which is a US corporation, has a site called Atlas where Microsoft, Airbus, McAfee, and a bunch of others have enumerated bugs, routine failures in machine learning algorithms, and also cybersecurity threats. And each one is evidenced by a system or situation that they've experienced. And I find that tremendously useful. So whenever I'm working on a machine learning application, I will go and use that Atlas taxonomy just to go through and say, could that happen? Could that happen? Yeah. So I do think we're making tremendous progress. Maybe not as quick as some other people would hope, but yeah.
Yeah, and just for context for the audience, so LIME is a technique in an area called explainable AI or explainable machine learning, where the idea would be to provide computational, so automatic way for a machine learning system to tell you why you did certain things. And there's many technical challenges, maybe in another webinar. And the second comment I would make, just for the benefits of the audience, was that it would be on fairness and the fact that there's many models and many techniques in AI that have been around for decades that produce these sort of biases. So it's not just the latest wave of AI that you've heard about. In fact, lots of predictive AI has produced horrendous biases. But we are making progress indeed with techniques and awareness and catalogs of incidents and red teaming to replicate. I'm good. I see there's lots of questions in the chat, which is great. I'll move us on to something that is very close to the agenda of the Open Data Institute, which is data. So in these safety critical AI applications, what would you say is the role of data? And in particular, does it matter where the data comes from, whether it's open data, privately held, shared? And I'm going to tell you that after that, I'm going to follow with a question from the chat because people are interested in data scraping.
No, I mean, I think it's such an important topic, and there's loads of things we can talk about. But best thing is to give you a personal example. Like I went on a climbing course once up in the north of Scotland, and you're in the middle of a complete whiteout. So there's snow everywhere. You've got a compass and a map. And the person that was taking the course said, okay, I want you to go to these locations. And so the group of us, about 6 of us, and we'll start walking. And at a certain point, he blows the whistle. And he says, take 1 pace forward and look down. So we took a pace forward and looked down, and there's like a 300-foot drop. And so we're all thinking, okay, this is obviously a learning experience that was designed to really scare us. But what's the point? So what he said was, never trust the map. And we had out-of-date Ordnance Survey maps that had been deliberately provided to us. And what happened was they had the only feature that you could see in those weather conditions was a ski hut. And the map had been published before the ski hut had been completed, and the ski hut was not in the location that it was intended to be. And his point was that if you rely on data and it's safety critical, then you have additional elements of due diligence that you need to put in place. And it was really funny as we left Fort William, which is where the course was, there were notices on the shop windows saying, if you have Ordnance Survey map, come and get a free replacement. And I think, that what I think is really concerning me over the longer run is things like large language models are now training themselves on the output of large language models, and where does that end? So, like in the case of government, which obviously I'm a scientific advisor to a government department, as it stands now, most of the data that we have is relatively pure, and we have the Green Book, which is a statistical guidance. And there's also a part of government called the Office of Statistical Regulation, which if you've not heard of, you should go look, because there is public guidance on the use of machine learning in statistics on that site. So right now, I think we've got things in a relatively well organized state in terms of data provenance. And there are mistakes, obviously, but the problems of provenance will get worse as we rely on secondary inferences as our data source for larger scale algorithms. And as the keepers of data that affects decisions on the public, we really need to be careful about that. So although we can use large language models in certain forms to support policy making across government, we really have to be aware of things like bias and also of the erosion of primary data in large-scale inference.
I was, for some reason, for the first time in 5 years, I'm receiving a call on the landline in my office. I didn't even know this thing still worked, but it does. And so, there was a question from the chat about our ability to potentially reconcile the scraping of public data provided by individuals for a specific purpose with wider data scraping by third parties for other purposes, including training large language models. So the question is, how do we reconcile it, and what are the regulatory privacy and security implications?
question, and it's really so. I'm in Parliament Street outside Parliament at the moment. Lots of people are still looking at those issues. A really good example would be in certain areas of the UK when you're a patient in the NHS, you can consent for your data to be used either for research purposes or for operational purposes. And for operational purposes, your data as you go through the healthcare system might be looking to optimize performance. And as a data subject, you have a good degree of control over that. Obviously, like if we want to improve the NHS, then Prime Minister and others have said that data is a key way of doing that. Then we have to really think about the purpose for which data was given and the purpose for which data can be used. And so I think what you'll see, and this is speaking purely from my own personal standpoint, is over the next 12 months, the government will have to make certain decisions, I think, about about the policy side of how data is treated. Because I think it's clear to most people that we can make our services more efficient and we can deliver. I should say, like, I'm associated with the healthcare mission, one of the 5 government missions. And one of the things they've asked us to do is to eliminate the use of ambulances as a way of, because the beds are blocked in the hospital. So you hear of patients being stuck outside a hospital for 6 hours and things. So we've been asked to work together, and I'm a data scientist. Let's eliminate that. In order to do that, we really need to understand the data and understand where the problems are, where the bottlenecks are throughout the system. And we may not have access, the patients that were involved in those bottlenecks that suffered those experiences at the start of their healthcare journey may not have decided to share that data. And so how can we work for the benefit of everyone? I think most members of the public would like to eliminate the use of ambulances in that way. But we have data protection, and I don't think we get multiple shots at this. So if we work in government and we ignore privacy issues, there will be a backlash, and quite rightly the public will say, Big Brother, what are the limits? What are the limits to what you're doing with our data? But I also think privacy enhancing technologies offer a huge range of technical benefits now that can really solve this problem. So I talk to people a lot about what's called homomorphic encryption, which enables a function to be computed over data but without release of the data. And the banks and other agencies in the UK already have begun limited use of it. But so I think there are a growing range of technical solutions that provide access to the data and still enhance privacy. I think the problems are that often they're computationally expensive. The people, for instance, in Department of Health and Social Care who want to be able to provide the benefits to the public aren't necessarily expert in those sorts of technologies. So it's a long journey, but I think I'm optimistic that we're heading in the right direction, and that the fundamental principles of privacy, but also service to the public, are what's guiding people. And the social aspects of all of the things we've discussed, I'm really surprised. I've only been in civil service 7 months, and I came in with all of they won't understand the social aspects issues. It's quite the reverse. I think people, the National Data Library and others are really sensitive about respecting privacy.
Yeah, thank you. And I would also point people to the ICO work on the public consultation and the response to the public consultation on large language models, which offers lots of answers and directions for future thinking and future research as well. And we do have, lots of examples of organizations doing this well. So sometimes there is a lot of backlash as well from certain sectors, from certain organizations say, oh, it can't be done, oh, it would hamper innovation. And that's true, and we need to be mindful of that. But then there's increasingly technologies like you're saying, but also lots of case studies where this can be done responsibly. So because as you were saying, we have one shot at this, and every time there is a public scandal about misuse of personal data, there's a million of people who opt out of sharing the data with the NHS, and then we're all worse off, basically.
The Information Commissioner's Office is part of DCAI, or is not part of, it's an arm's-length body. So it's one of these organisations that we work very closely with. And I think they're very clear about, because quite often when you talk to members of the public, they have attitudes to data that may or data protection that may or may not be correct. So a really good example would be during a flood a few years ago in the north of England, the NHS were concerned about disclosing data about people with reduced mobility to the fire and rescue service. And the issue being that they felt it was covered by data protection, and the fire and rescue service needed that information to go and rescue people, to go to the flooded houses if they couldn't escape themselves, and make that a priority. And the Information Commissioner's Office, when you discuss examples like that with them, are very clear that if there's a safety of life issue, then that is. That takes priority, saving lives in that situation. But then there's kind of going into the nuances of how data could be used. Another thing that I really care about is, I was at a meeting earlier this week on personalized prevention. So personalized medicine is taking your DNA and other individual characteristics and trying to come up with a drug administration program that's tailored to you as an individual, not to every male person of a certain age or whatever. But personalized prevention is using that information to try and prevent disease in the first place. And that, from a machine learning point of view, I think that really typifies the technical and the social issues about why we're in a new world and why this is so complicated. So, like in the past, if you were looking at, if people got certain workplace diseases and they'd been exposed to asbestos, you could have a pretty good understanding that the asbestos had a causal relationship, or a strong causative relationship with the disease that you suffered. But if you look at, say, personalized prevention, what that's saying is that there are many factors that might contribute in your lifetime to a disease. If you change your behavior, that might prevent you from getting sick. It's then far more difficult to identify what things in your life, with your genetics and other things, might actually play a causal role in preventing you from getting disease. So which one of the 63 things that you did over the last year prevented you from getting sick? Does that make sense?
Yeah, absolutely.
It's far more. To me, if we can get that right, the implications of that are enormous in terms of health and social care. And my dad's got dementia at the moment, so I kind of look at this in a personal lens, and I think that personalized prevention offers huge opportunities, but for machine learning in particular, there's a huge challenge to identify and be able to then control what factors lead to a disease as terrible as that.
Yeah, some people say that you could do a lot of this work, including this prevention use case you've just mentioned, with synthetic data. How do you see that? Where do you see the opportunities? Also, because you've mentioned before that you're potentially concerned about AI using AI generated data, or at least using it all the time.
Yeah, no, I think yeah. I think what you get, especially in the synthetic data, are people who are real evangelists of the use of synthetic data. And I I'm too old to get that enthusiastic. I kind
Yeah.
of, at one point in my life, I was working as part of a joint European NASA space mission, and we had 3 simulators, none of which accurately modelled the state of the real world satellite. And we spent all our time arguing about whose simulator was best and actually looking at the data that was coming off the spacecraft. And I think with synthetic data, if it's used in the right way, with the right checks and balances, and not as just a shortcut to doing the verification and validation, which is a phrase we would use, then I think it's tremendously useful. But there is always the danger that you amplify emissions through the use of that kind of approach.
Yeah, thank you. And you said something very important there about how we deal with this data, right? How it is stewarded, how who has access to it, to which degree do we as individuals have agency. There's a lot of very interesting discussions in the chat about that. But I suppose another question that people have raised in the discussions is this questions around the provenance of the data in general, whether that's personal data or sensitive data for other reasons. Do we have the technical or the regulatory instruments to know what data has been ingested in these systems?
And I think it's a really good point. And I think, you know, even with a conferencing system like we've got on now, it's possible to get machine learning add-ons that then store the data and use that in further inferences and provide, you know, the notes and summaries that people would have seen from the extensions to those systems. And kind of it's impossible for somebody participating in the meeting to anticipate what the use of their own words would be by those systems in the future. Like, I don't know, you know, will it, if somebody issues a query to that system in the future, say, what did Chris Johnson say, you know, 3 months ago on data and machine learning in the UK government? And so I think there's a need for people to at least be aware of the personal privacy and security implications of the use of, on the integration of machine learning into everyday products like teleconferencing systems.
Yeah.
And what's really important is that social etiquette hasn't caught up. So many people that are on a conference where we have a note-taking assistant running alongside it may not understand that their words are contributing to the data that model will then use in the future.
In fact, someone just posted on this on the chat.
Well, there you go.
That, you know, Otter AI is going to basically know everything we have ever spoken about.
That's exactly right. You know, and to be honest, like, there was a discussion a few years ago came out, I think, Google, but the government, the UK government, got involved as well, which is this right to forget. Yeah. And I think that's really important, you know, because
how would that technically work?
I don't know.
Without destroying the models and asking them to train from scratch.
I don't think people really thought about that. But people's political views change. People's attitudes change. I think you know. There's a safety and an anonymity in the scale of many of these things. But you know, when you have a public office like mine, I have to be aware of that something I might say today could influence an answer or a query in many years' time. And I think everybody that's, especially early career researchers and young people that are on the call, you really need to be aware of that. So, you know, something that you might express in public now could come back in 10 years' time and have a really big impact. Because we don't have that right to forget. And that right, you know, in machine learning, there's this thing called monotonic learning, which is you only add rules, right? And I think that's the real tyranny of machine learning as it stands right now.
Yeah, so I think it's a huge space, right? I'm not a machine learning researcher myself, but there's techniques like machine unlearning that people are experimenting with. But essentially, everyone needs to understand that it is different than the right to forget. So right to forget, as it was implemented with, say, search engines, was already quite complex because Google was using a lot of deep learning even before we all have heard of deep learning and generative AI. But there were mechanisms that were put in place to track the provenance of data they were using. And it's the same sort of mechanisms you would want to have as well, to get back to that question about provenance. But Google can afford to do that. Not many companies are in this situation. Let me just move us on to another question that takes us more into geopolitics. And this is a very interesting week that we're living through, obviously. But the question refers to the announcement, yesterday's announcement of President Trump, worth, I don't know how many hundreds of billions of dollars in AI infrastructure investment in the private sector. So OpenAI, Oracle, and I think a third company I don't remember are involved in that. So the question is, do you see this announcement and everything else that is coming out of the current administration? How do you see this impacting outside investment in UK data and AI systems? And the follow-up question is, what aspects of the recent AI action plan do you see as most strategic to position the UK with respect to US and China? It's not my question.
No. Well, it's a fair question. I mean, I think globally there's a realization of the opportunities that machine learning can offer, and there is a view that compute is the magic that will increase the ability of ourselves to kind of benefit from the opportunities technology provides, and so building large-scale data centers is one approach. But to me, that's about 2% of the issues. I think it's really important to have the ability to be able to do the computation, and typically we're talking about large language models and frontier AI. I'm more concerned about the narrow models which are used in industry or in autonomous vehicles, things like that. But that's another set of issues. Mm-hmm. Just retraining one large language model costs in excess of £200 million for one shot, and there may be several of those across a 12-month period. The scale of that, both in terms of climatic impact as well as finance, is enormous, and there are huge implications to that. Because these models are often not value neutral, so there's a concern that these large language and generative models are in some sense safe. What that means is that they won't answer certain questions, or they won't represent certain forms of bias. And that means that you put rules on the generation of the models. You say, okay, you won't look in this area because we don't want people looking at this sort of stuff. This is just going to propagate, say, pornography or whatever it is that you want. And while across the world we can agree on certain core values, they're not universally held. And so, say, there's a lot of investment in the UAE in large language models because they don't necessarily want to have a model that reflects Western preconceptions about society. And so as the computational overheads associated with the generation of large language models increases and the number of companies that are able to produce them decreases, I think there's a real set of cultural issues about how we maintain the values that we hold to be important in the technologies that our children access. So the geopolitical, I think it would be wrong to not ask that question. Nobody knows the answer. The Digital Technologies Unit, I'm sure I've got the name wrong, but the digital part of the Competitions and Markets Authority, I think, has published some really interesting reports on those interactions. And from a UK perspective, we probably can't afford to get into an arms race over the number of compute cycles that we would need in order to generate a UK PLC large language model. Well, I mean, maybe we'll just take the decision that that's something that is worth investing for the reasons that I just expressed, but it's not value neutral.
And there's potentially other areas. I mean, you've mentioned certain countries or certain parts of the world wanting to have models that reflect how they think and their own values and beliefs. There's also a question of language. In all those countries, because lots of the models are trained on public content, and the amount of content available in most languages is very small. So then you need dedicated investment in data and training to get to similar levels as, say, for English or French or any of the big languages. I would also point people to techniques that have come out of China, like DeepSeek. Say China has been struggling to get access to certain types of technologies and innovations in the last years. It isn't something that has changed since this week. And what that meant, among others, and I'm speaking now as a scientist, is that they have come up with a number of very interesting technical architectures that are able to do training on fewer GPUs, on weaker compute infrastructure. And some argue that they've done that because there was no alternative. And the models so the open source models that they have that came out in the last 6 months are quite powerful. And even if I just look around the lab or in the community, there's lots of people using them. So there's many ramifications as you said. I'm just looking at the time. I think we have time maybe for 2 questions, and I'm going to move us away from the technology a little bit. There was a question in the chat about how would you envisage managing, whether managing is the right word, the human in the loop in AI, a seemingly essential part of AI systems that manages risk, but is in itself potentially a failure point. So what's the role of people, and what's the role of users of AI systems?
It's a great question. So in a lot of the systems that I've been developing, there's a requirement to have humans in the loop, but often the people that write that don't really understand how the existing systems work. So many of the conventional systems that we operate today are uncontrollable by a human. So the human might have a stop button, but they've not got the time to press it.
Yeah.
The best example I know is that a friend of mine ran a helicopter company, and in the old days they fly by wire, so the computer controls the flight surfaces of the helicopter. And in the old day, there was a pedal that he or she could stamp on and turn the software off and take direct control of the flight. They realized that the helicopters were becoming so powerful and the computer control was so embedded in control surfaces that it was more dangerous for the pilot to take control. So the problem then was, well, how do you guarantee the safety of the software and of the crew on a test flight? So what they did was they put all of the software engineers' names into a glass bowl, and then they drew out 2 of the names of the software engineers, and then they had to fly on the test flight to improve the software. So that's got, even without machine learning, we're in a situation where most or many really top-end safety critical systems are not human controllable within the timescales that need to be, intervention is needed. So that's the first point. Second point is humans are incredibly fallible. And, I worked as a safety engineer before machine learning, during the very, very first 1980s sort of first generation in the UK and the Alvi project and AI and machine learning. In that stage, I was working on safety critical systems, and you know, I the most common feature of working as an accident investigator or accident analyst was that humans were always involved at some stage. Even if they didn't directly cause the problem, they may have observed it in a test case and not responded appropriately and so on. So it's kind of like, you know, I think it's a really complicated topic, and human computer cooperation, to me, in terms of the future trajectory of systems, is really where I think we will end up. And so you mentioned things like explainable AI or interpretable approaches. I mean, these to me are where we probably will end up. I mean, I'm also aware, we're talking about cultural differences, that the kind of tests that we do in some contexts are not those that are done in other parts of the world. So the regulatory environment that we work in is quite constraining. And for us, we're kind of trying to get a sweet spot, as I mentioned before, like the Regulatory Innovation Office is trying to be able to create a situation where we can compete globally, and at the same time have software that reflects the values that we hold close. And that's really difficult. You know, you know, there's this idea of proportionate risk taking, and if you treat novel systems with machine learning in like a conventional system, you probably wouldn't use them at all because the uncertainty over learning and so on is so great. But if we do that, the future generations will always be on the back foot in terms of innovation. So, like I said, it's a topic that I really, really care about. I don't know all the answers at the moment, but getting the balance between growth and safety is absolutely the center of what I do most of my days here.
Excellent. I'm going to that brings me very neatly to the final question I'm going to be able to ask you today. Jan is asking, what are 2 things that you're most excited about in AI and 2 things that you most worry about in AI over the next 5 years? So maybe the worry first, and then the exciting things at the end.
I can't, like, it's a really good question, but it's one that I would take a longer time to think about. The thing that I worry about is ultimately I want to be able to look my kids in the eye and say that I did the best that I can. Because lots of the issues that I am dealing with and that we're dealing with in this building will affect future generations. It's a bit like I was describing about that balance between risk and innovation. It's not just hypothetical. Like, so let me give you a really concrete example. So one of the discussions we're really interested in at the moment is how do we integrate UAVs into civil airspace? Drones, autonomous flying vehicles, right? And there's a perception that perhaps we've been too cautious and that there's great opportunities to be gained. Obviously, if we do that in an uncontrolled fashion, there's a potential for an aircraft to ingest a drone into an engine and hundreds of people could die, or a drone could come down on a congested space like a school and again injure people. So there are lots of things that we could do. So, for instance, we could fly drones up rivers, we could fly drones on railway tracks, but then that introduces other forms of risk as well. And we have to kind of make really difficult judgments about how fast the UK and other countries wants to go in that there is this opportunity. Another example would be getting medicines very fast to the scene of an injury, or getting advice to people really fast. Surveying, you can see it already happening around us. And in certain contexts, people have taken the opinion that the benefits to the public outweigh the risks, and that's why I'm both scared of what can happen, but also really, really excited about the opportunity. Like I cycle around central London. I don't want to wait for 25 minutes for an ambulance to come.
Yep.
If I have an accident, So yeah. But that's on me. Like why I've taken this job and why I work with organisations like the Health and Safety Executive is that I really care about it, and I think it's too easy to say we don't have AI here, we ban drones because they're too dangerous. To me, I would really want to engage in that discussion and hold at least part of the responsibility for the decisions that lie ahead in getting the benefits of machine learning, and also understanding what can go wrong, which, as I mentioned before, the Grenfell fire to me typifies a situation where the part I was responsible for was to do with the use of radios and technology, and arguably there was a need to embrace technology faster to ensure that there was a better picture of the people that were injured and trapped in that building. And I want to make sure that where we can, we make sure that technology is available to protect citizens, for instance. And to do that, we need to create a regulatory environment, rules that enable us to get the benefits in a proportionate way. So it's a really personal thing to try and make sure that government keeps up to pace with what's possible technologically, but also know that if we go too far, then that'll be on my conscience.
Thank you. And I think it's a good note to end. I hope many people who attended today can relate to that. I have to show one more slide before we wrap up for today. But thank you to everyone in the audience for joining us and putting your questions to Chris. I managed to go through most of them, but I know people also had conversations in the chat which were very interesting. We'll share the recording. As I was saying at the beginning, this is part of our data-centric AI program at the ODI, and if you want to know more about it, there is a QR code that will take you to a newsletter you can subscribe to, where we are going to share the recording, but also some of our own thinking and work in this program. And among other things, we've been discussing recently about the National Data Library, which Chris mentioned as well, as one of the areas in which his department is working. So here on the slide, I've added a screenshot of a recent paper that we're going to present at a workshop with Wellcome and the ESRC next week. I hope to see lots of you in February to our 7th webinar. So in this webinar, we are going to present for the first time our own work, which is the ODI's AI Data Transparency Index, where we have assessed the number of foundational frontier models with respect to their practices in data collection, data assurance, and so on and so forth. And with that, I hope to see you all there in February. Thank you very much, Chris, for your time. I know you're very busy. Thank you, everyone, for attending, and I see you hopefully next time. Bye-bye.
Thanks, everyone.
Thank you.
Thanks.